Okay, so I want to talk about finding domains. We kind of did this when we were solving rational equations and we had to figure out what x could not be. Same thing here. But I want to talk about two easy ones first. I think they're easy. I think you'll think they're easy also. The first one is a polynomial. Now, we all know what polynomials are. Polynomials don't have x's in the denominator, and they're not under square roots and stuff like that. So polynomials, here's a, straight up example of a polynomial. For polynomials, the domain is written like this. This means all real numbers. This notation is special notation for all real numbers. So the domain for any polynomial function is all real numbers. The only way you can tell it's a polynomial function is if it doesn't have x's in the denominator and it's not a square root. So I don't want to focus. So those are the easy ones. I don't want to spend too much time doing these. But polynomials, no x's in denominator, no square roots. Okay. Let's talk about square roots. Here's a square root function. All right. In order to find the domain of a square root function, you have to remember what's underneath this number right here has to be greater than or equal to 0. Remember, you can't have a negative under a square root symbol. So we use the fact that what's underneath is greater than or equal to 0 to set up an inequality. So we'll take the x minus 3, set it greater than or equal to 0, and solve for x. Now, this goes back to when we were solving inequalities. This is the domain, but the domain is written in that special interval notation going this direction. All right, let's do some more of this special type. Let's say my function is the square root of 6x minus 8. And I want to find the domain. Find the domain. All right, so I'm going to take what's underneath here, what I've got circled in red, bring it down, put it greater than or equal to 0. Now we're going to solve for x, so we're going to add 8 to both sides. Divide by 6. X be greater than or equal to 4/3. So the domain will be a bracket 4/3, comma, infinity. Let's do another one. Let's say I have f of x is equal to the square root of 14 minus 2x. All right, so we're going to take what's underneath. I'll circle it in red again. Take what's underneath, bring it down, put it greater than or equal to 0. All right, so I'm going to move the 14 over, and when we're moving across the equal sign, it's going to be a negative 14. Dividing by negative 2, and remember, when you divide by a negative, you have to flip the inequality symbol. All right, so based on this, my domain is, this time it's going to negative infinity. So the whole key to the square roots is taking what's underneath, setting it greater than or equal to 0 every time. Now, what we mainly want to focus on is rational functions. Let me erase that. So we want to find domains for problems that look similar to this. Maybe x, here's our function, x over x minus 3. This goes back to when we were solving rational expressions, or rational functions, and we had to decide what x could not be. You know, there's always a number that x can't be when you have a denominator with a variable in the bottom. So remember, if we have x minus 3, the x could not be a positive 3 because that would make that a 0. This tells me that the domain contains everything except the number 3. That's what that means. The domain has everything, contains everything but a 3. Can't spell 3. Now, unfortunately, we can't write it like that. We have to write it in interval notation. Now, the interval notation, I need y'all to hear this. It's going to have the symbol, looks like an uppercase U. This is called the union symbol. We've got to change x is not equal to 3 into something involving union symbols. Now, hear this, listen to it, replay if you have to. Since there is one restriction on x, I'm going to have 2 parentheses and 1 union symbol. On the left, you'll put negative infinity. On the right, you'll put positive infinity. Whatever the number is that we just figured out, that goes in both parentheses. One restriction on x means you've got 2 parentheses with a union symbol in the middle. Negative infinity on one side, positive infinity on the other. Let's look at this one. Let's say f of x is equal to 3x over x minus 6, x plus 7. All right. Now, there are 2 binomials. Since there are 2 binomials, there are 2 values for x that I can't have. According to this one, x cannot be a positive 6. X cannot be a negative 7. Remember, the signs are just opposite. Okay. Because I have 2 values for x, I'm going to have 2 union symbols, and my answer will look like this. You'll have 3 sets of parentheses. You'll have a negative infinity on the left and positive infinity on the right. You put the numbers in the parentheses, smallest to biggest. So on the left side, that left parentheses will have a negative 7. In the middle, you will always have both numbers. smallest to largest. And then on the right, you'll have the largest number. 2 values for x means 2 union symbols, 3 parentheses. If I had 3 values for x, I would have 3 union symbols. I don't think I'm going to have any of those, but pay attention to what this looks like. Notice I don't care about our numerator. That has nothing to do with it. Ignore the numerator, just work with the denominators. Now let's look at this one. I don't want glasses. All right. Let's say my function is 7 over x times x plus 9. All right, now this goes back to what we did when we were solving these equations. Because there's an x on the outside, one of my numbers cannot be 0. This x plus 9 tells me x cannot be negative 9. All right, so we have I've got my 2 answers. I'm going to have 2 union symbols, 3 sets of parentheses. All right, so negative infinity on the left and the smallest number. Both numbers go in the middle, and then the biggest number's on the right with the infinity symbol. Now, those were factored for you. We're going to have to factor most of them ourselves. So let's just take a function. Let's say we got, I don't know, 8 over x squared minus 5x plus 6. The first thing we're going to do is factor our denominator. So always factor your denominator. This one factors into x minus 3, x minus 2. We factor this one, no telling how many times. Now, let's figure out our restrictions. According to this one, x cannot be a positive 3. According to this one, x cannot be a positive 2. All right. So we've got 2 numbers, 2 union symbols, 3 sets of parentheses. Negative infinity is on the left. The smaller of the 2 number goes next. Then both numbers go in the middle, smallest to largest, and then the largest goes on the right with the positive infinity symbol. Let's do another one. Whoops. Let's go back to black. All right, so f of x, let's say we have, I don't know, x minus 8 over x squared minus 4. So again, I don't care about the top. I just care about the bottom. So we're going to factor the bottom. Whoops. X minus 2, x plus 2. All right, now we're going to figure out the domain based on what the x cannot be. According to this one, x cannot be positive 2. According to this one, x cannot be negative 2. All right, so we've got our 2 union symbols, 2 sets of parentheses, put negative infinity, smallest number, and both numbers in the middle, and the biggest and infinity on the right. The biggest thing to this is knowing how to factor. Once we get it factored, it's going to set up the same way every time. We've got to remember 2 values for x gives me 2 union symbols. Now, I want to do one that's a little weird, and it's going to involve two square roots, just to kind of show you how this works. So let's say we had x plus 2, then we had plus square root of x minus 6. All right, since we've got two square roots, we've got to figure out both of them separately, and then we're going to figure out what the final answer is. Now we said do this just like I did earlier. We're going to take the x plus 2, set it greater than or equal to 0. We're going to take the x minus 6, set it greater than or equal to 0. When I get this one, we'll have negative 2. When I solve this one, we'll get positive 6. When we've got two square roots, when we've got two square roots, we need to draw a number line and shade. All right, wherever they overlap, that's the answer. So let's draw a number line. Here's my negative 2, and here's my positive 6. Now, if I were to shade greater than negative 2, I would go this direction. Now I want to turn around and shade greater than 6. I'm going to use a different color. I guess we'll use yellow. Now I'm going to start at 6. Now don't look yellow to me. I'm going to start at 6 and we're going to go this direction. To write the final answer, we look to see where it's shaded exactly on top of each other. Now notice the shading starts right here. When you've got two square roots, one of the square roots is going to override the other one. They're not both going to be the answer. It helps to sketch the graph. Whichever one overlaps, that's the piece with the domain. So the domain will be starting at 6 and going to positive infinity. So again, two square roots, you find both of them, you sketch them on the number line, and where they're overlapping, that's the answer you use.